Right now, behind the screens of Silicon Valley and the bright lights of American cities, something quiet and dangerous is happening to the electrical grid. We talk a lot about artificial intelligence, new microchips, and massive electric vehicle fleets, but almost nobody talks about the massive metal boxes sitting on concrete pads outside our neighborhoods and substations. They are called transformers. Without them, electricity from a power plant cannot enter your home, your office, or a data center. Here is the terrifying reality facing the United States today. The American power grid is old. More than 70% of the nation's high-voltage power transformers were installed over 25 years ago. Many have been operating for more than 4 decades, far past their intended lifespan. Under normal conditions, this aging equipment was already struggling. But now, the explosive growth of AI supercomputers, massive server farms, and electric cars is demanding more raw electricity than the grid was ever built to handle. When a major transformer breaks down in America today, you cannot simply go to a warehouse and buy a replacement. Before 2020, ordering a custom high-voltage transformer took about 50 weeks. Today, American utility companies are being told they have to wait 3 to 4 years for a single replacement unit. Let that sink in. A 3 to 4 year wait time for the basic hardware that keeps modern life running. Prices for these massive components have jumped by over 300% in just a few years. This delay is not just an inconvenience. It is a massive bottleneck that threatens to bring the American technology sector to a sudden halt. AI tech giants like Microsoft, Google, and Amazon are spending tens of billions of dollars on powerful chips. But those chips are completely useless if there are no transformers to feed them power. Power companies are literally telling data center developers that they cannot connect to the grid for years because the hardware simply does not exist. While the West is facing this massive equipment shortage, engineers in China took a completely different approach. They did not just try to build traditional transformers faster. They looked at the core material science of power distribution and realized that the old design, which relies on heavy steel, copper, paper, and liquid oil, had reached its physical limits. They asked a simple question: what if we could build a transformer using one of the most common materials on Earth? What if we could solve the world's power grid crisis using sand? To understand why China's sand-based discovery is such a big deal, you first have to understand why traditional transformers break down in the first place. Inside every standard transformer, there are copper coils carrying enormous amounts of electrical energy. As electricity flows through these coils, resistance creates intense heat. If that heat gets too high, the copper melts, the system short circuits, and the whole thing fails. For over 100 years, the global power industry has relied on the exact same trick to keep transformers cool: liquid oil and paper. The copper coils are wrapped in special insulating paper, and the entire metal tank is filled with thousands of gallons of heavy mineral oil. The oil absorbs the intense heat from the coils and circulates it away. On paper, it sounds like a simple system that works fine. In the real world, this reliance on liquid oil and paper is a ticking clock. As transformers run under heavy loads day after day, the heat constantly bakes the paper insulation inside. Over time, that paper degrades, breaks down, and loses its insulating power. Even worse, the mineral oil inside the transformer degrades as it heats up and cools down. Moisture and tiny air bubbles start to creep into the fluid over time. When a transformer is pushed past its limits, like during a summer heat wave when millions of air conditioners are blasting, or when a nearby AI data center suddenly pulls massive amounts of current, the oil reaches extreme temperatures. Water and gas bubbles in the degraded oil create a path for electricity to jump. When high-voltage electricity jumps through hot oil, it creates an electric arc that reaches thousands of degrees in a split second. The result is violent and explosive. The mineral oil instantly vaporizes into flammable gas, pressure builds up inside the sealed steel tank, and the transformer bursts into a massive ball of fire. These catastrophic explosions do not just destroy millions of dollars worth of equipment, they knock out power to thousands of homes and take down entire regional substations. This thermal limit is the exact wall the modern energy world has crashed into. We are trying to run a 21st century digital economy on 19th century liquid oil and paper technology. American and European engineers have spent decades adding cooling fans, bigger radiators, and complex monitoring systems to squeeze a little more life out of these oil-filled units. But no matter how many sensors you attach, oil still boils, paper still degrades, and hot fluid still burns. The fundamental problem was never the copper coils or the outer steel shell. The fundamental problem was the liquid insulation itself. If you want to build a transformer that can handle double the power without melting down or blowing up, you have to get rid of the liquid oil entirely. You need a solid material that can stop high voltage electricity in its tracks, withstand extreme temperatures, and never catch fire. And that is where sand comes into the picture. When you look at a handful of ordinary sand on a beach, you are looking at quartz, which is made of silicon dioxide. For decades, the global technology sector used high-purity sand to make computer chips and solar panels. But Chinese materials scientists asked a completely different question. Could processed sand be used to replace liquid mineral oil and paper inside ultra-high voltage transformers? The journey from loose beach sand to a revolutionary super transformer comes down to advanced chemistry and extreme engineering. Chinese researchers took ultra-pure silica sand and processed it through high-temperature reactions to create advanced silicon carbide ceramics and specialized solid-state epoxy resin matrices. Instead of soaking copper coils in thousands of gallons of flammable oil, they embedded the electrical components inside a solid, high-density matrix derived entirely from refined silicon sand. This solid-state approach completely changes how a transformer handles extreme high-voltage power. Silicon dioxide and silicon carbide have a molecular structure that naturally resists massive electrical stress. Electricity simply cannot jump through this solid material the way it sparks through aging liquid oil. The dielectric strength, which is a material's physical ability to stop electricity from leaking through, is far superior to any traditional liquid mineral insulation. Even more impressive is how this material handles extreme heat. Traditional transformer paper begins to char and disintegrate once temperatures cross 100 degrees Celsius. This sand-derived solid insulation, however, can easily withstand continuous temperatures of hundreds of degrees without degrading, shrinking, or losing its structural strength. Because there is no liquid oil inside the tank, there is literally zero risk of fluid boiling, zero risk of internal pressure buildup, and zero possibility of a catastrophic explosion. If a surge of intense power rushes into a sand-based super transformer, the solid-state material simply absorbs and spreads the thermal energy across its dense structure. It acts as a massive heat sink that naturally radiates thermal energy outward without needing noisy, complex external pumps or heavy oil radiators. For the power industry, this is the equivalent of replacing fragile glass light bulbs with solid-state LEDs. Chinese manufacturing lines can cast these solid insulation blocks with absolute precision, eliminating human assembly errors and avoiding the long, delicate drying processes that traditional oil and paper transformers require. By utilizing Earth's most abundant resource, ordinary sand, Chinese engineers created an insulation system that is non-flammable, virtually indestructible under normal operating conditions, and capable of lasting for decades with almost no physical maintenance. But building a better solid material in a lab is one thing. Testing it under the world's most extreme power grid conditions is where the true disruption began. Having a solid material built from refined sand is a massive laboratory victory, but putting that technology onto an actual power grid is where the stakes become truly massive. To see why this solid-state technology changes global infrastructure, you have to look at the sheer scale of China's modern energy grid. While the United States and Western Europe transmit electricity across regional lines using standard high-voltage lines, typically between 230,000 and 500,000 volts, China built something completely different. Over the last 15 years, China constructed the world's largest ultra-high voltage transmission network. Their lines operate at up to 1.1 million volts. To put that into plain English, China is pushing massive rivers of electrical current across thousands of miles, moving power from giant solar farms in the western deserts straight to industrial cities on the eastern coast. Driving that much electricity through a standard transformer would generate so much internal heat that a traditional oil-filled unit would literally cook itself from the inside out within minutes. This is where the sand-based supertransformer proved its true capability. By deploying solid-state silicon insulation across their ultra-high voltage substations, Chinese utility operators created transformers that can handle extreme energy density without swelling, leaking, or exploding. Because these solid-state units operate at much higher thermal limits, they can pass roughly double the electrical throughput of a standard Western transformer while occupying a significantly smaller physical footprint. Think about what that means for grid operators. In a traditional substation, adding more power capacity means clearing acres of land, building massive concrete firewalls to contain potential oil explosions, and installing heavy fluid pumping stations. With sand-derived solid-state transformers, you can step up the voltage by 50 to 100% inside the exact same physical space, without needing explosive oil containment basins. In real-world operational stress tests, these sand-based transformers demonstrated near zero thermal loss, maintaining high electrical stability even when pushed under intentional overload conditions. Where traditional paper and oil insulation begins to break down after a few hours of intense summer heat, the solid-state matrix holds its structural geometry without weakening. While Western grid operators spend millions of dollars monitoring liquid oil samples, replacing degraded paper, and worrying about catastrophic fires during peak demand, China's grid is running on solid, non-flammable hardware that simply does not break down under heat. They didn't just build a better component for an old grid. They built the foundational hardware required to run a megagrid that can move clean, heavy energy across an entire continent without losing control. This technological gap between traditional oil-filled transformers and solid-state silicon hardware is not just a distant engineering debate. It is a direct and immediate threat to the American economy. Right now, the United States is trying to win three massive technological races at the exact same time, leading the global artificial intelligence boom, reshoring advanced semiconductor manufacturing to domestic soil, and transitioning millions of drivers to electric vehicles. Every single one of those three goals depends entirely on having a massive, reliable supply of raw electricity. A single AI data center cluster built by companies like Microsoft, Meta, or OpenAI can demand as much power as a medium-sized American city. A single modern microchip fabrication plant requires perfectly clean, uninterrupted, high-voltage power every second of every day. If the voltage drops for even a fraction of a second, hundreds of millions of dollars worth of silicon wafers are instantly ruined. American tech giants are rapidly discovering that the real bottleneck to the AI revolution is not finding enough coders or designing faster chips. The bottleneck is the power grid. Silicon Valley executives are traveling across the country looking for locations to build new data centers, only to be told by local power utilities that there is simply no capacity available. Electric utilities are turning away multi-billion-dollar projects because they cannot secure the high-voltage transformers required to connect them to the main power lines. While American utilities are forced to wait 3 to 4 years for old-style, oil-filled transformers manufactured with long, fragile supply chains, Chinese manufacturers are producing compact, highly efficient solid-state transformers using readily available raw materials like sand and local resins. This means China can construct, power, and bring a massive AI data center online in a fraction of the time it takes an American company just to get permission to plug into an aging grid. The economic consequences for everyday Americans are already starting to show up on monthly utility bills. Because aging transformers are constantly failing under heavy summer and winter loads, U.S. power companies are spending billions of dollars doing emergency repairs and paying massive surge prices for replacement parts. Those extreme maintenance costs are passed directly down to American homeowners in the form of rapidly rising electricity rates. The reality check is stark and simple. The United States cannot maintain its position as the world's leading economic and technological power if its digital infrastructure is built on top of a physical power grid that is falling apart at the seams. While the West focused its investments on software, social media, and financial algorithms, China quietly focused on heavy industrial material science. They mastered the foundational hardware that actually delivers power to the modern world, leaving Western technology giants standing in line, waiting for transformers that may take years to arrive. When we look back at the defining technology races of history, we usually remember the flashy headlines: the first satellite in space, the fastest microchip, or the smartest artificial intelligence model. But history shows that true power belongs to the nations that build and control the physical foundations underneath it all. For the past 50 years, the United States built the digital world. American companies created the software, designed the smartphones, and built the internet platforms that billions of people use every single day. But software cannot run without electricity, and electricity cannot flow without heavy industrial hardware. China's sand-based supertransformer is much more than just a clever engineering trick. It is a profound material science breakthrough that solves one of the most critical vulnerabilities of the modern era: thermal decay in power transmission. By taking ordinary silicon dioxide, the very sand beneath our feet, and converting it into advanced, non-flammable solid-state insulation, Chinese engineers eliminated liquid oil explosions, doubled thermal efficiency, and unlocked a level of grid reliability that Western countries can currently only dream of. As we move deeper into the 21st century, the ultimate global bottleneck will not be who has the best algorithms. It will be who can supply the massive gigawatts of energy needed to run those algorithms without their power grid catching fire. America's 4-year transformer wait times and decaying infrastructure are no longer just maintenance headaches. They are a direct threat to national competitiveness, technological leadership, and economic stability. The revolution of modern power distribution didn't start with complex software or high-stakes geopolitics. It started in a laboratory, by reimagining what can be built with a simple handful of sand. The question facing America today is simple. Will the West continue trying to patch up a 100-year-old grid with fragile oil and paper, or will it wake up and rebuild its foundational industrial infrastructure before the lights quietly go out? Drop your thoughts in the comments below. Has the West lost its edge in heavy infrastructure, or can America rebuild its power grid in time? If you found this breakdown eye-opening, hit that like button, subscribe, and share this video. Thanks for watching, and we'll see you in the next one.